All right, so back in section 7.2, we had a formula that said this, sine of s plus t. How did the sine formula work again? Sine of one of them, cosine of the other, plus, and then it switched. So then it goes cosine s sine t. All right. So if I asked you for sine of 2x, this is known as a double angle formula because I'm doubling my angle. I could write this as sine of x plus x, and then I could use that formula up above. So that would be sine x cosine x plus cosine x sine x. Or I could write it as 2 sine x cosine x. So that's known as the double angle formula for sine. Sine of 2x, when you double your angle, you get 2 sine x cosine x. So there's our first new formula for today. I could do the exact same thing with cosine. What was our formula for cosine of s plus t? Cosine, cosine, minus sine, sine. Well, I wrote them in a weird order, but it's still correct. Should put the sine s first. But still the right answer. All right, so cosine of 2x would be cosine of x plus x. So that would be cosine x minus sine x sine x. So cosine of 2x is cosine squared x minus sine squared x. Tempting to say that's 1, but it's not. Cosine squared plus sine squared would be 1. But I could do this using that Pythagorean identity. I could also write this as cosine squared x minus, what's another way I can write sine squared? Using that Pythagorean identity. 1 minus cosine squared x. I distribute this minus sign through. I end up with 2 cosine squared x minus 1. Yes. So,
do we have to?
No, but we're going to want to. It's coming. You'll see. Or I could do this if I was in a crazy mood. Cosine of 2x is cosine squared x minus sine squared x. Instead of writing cosine squared x, I could write 1 minus sine squared x. So I would have 1 minus 2 sine squared x. In other words, what I'm getting at is for cosine of 2x, there are actually 3 different answers that we use depending on what we have and what we need. So one answer for cosine 2x is cosine squared x minus sine squared x. Another correct answer is 2 cosine squared x minus 1. And yet another correct answer is 1 minus 2 sine squared x. So for sine, we have one double angle formula. The sine for 2x, the sine of 2x is 2 sine x cosine x. For cosine 2x, however, we get 3 different formulas. And we will see in a few minutes here, looking at some examples, that sometimes we want one and sometimes we want the other. And sometimes we want the third. We got 3 options to choose from.
tangent?
What about, I'm glad you asked. What about tangent? What was our formula for tangent of s plus t? Yeah, that one's the hard one to remember. That one has tangent s plus tangent t divided by 1 minus tangent s times tangent t. So tangent of 2x would be tangent x plus tangent x over 1 minus tangent x. So it's 2 tangent x divided by 1 minus tangent squared x. And again, we only have one answer for that one. Questions on that?
Can't do anything with the 1 minus tangent squared.
You could factor it as 1 minus tangent x times 1 plus tangent x. But other than that, no, there's really nothing you can do with that, unfortunately. All right. So, first example. Determine sine of 2x, cosine of 2x, and tangent of 2x, given that sine of x is minus 3/5 and x is in quadrant 3. I'm actually going to find cosine first. Cosine of 2x is. To find cosine of 2x, I have 3 formulas I can pick from. Which one do I like? A, B, or C? I hear votes for B, I hear votes for C. I don't hear anybody picking A.
Hey,
A, all right.
let's do it.
No, A is not the right one. C is the right one. Why would I pick C? Because what I know is I know sine. I know sine of x is minus 3/5. So formula C only uses sine of x. So to find cosine of 2x, in this case, I would use C. If I happened to know cosine, then I would have used B. But because of what I know, I'm going to use C. So this is 1 minus 2 sine squared x. So that's 1 minus 2 times negative 3/5 squared. That's 1 minus 2 times negative 3/5 squared is 9 over 25. So I multiply by the 2, that's 1 minus 18 over 25. What's 1 minus 18 over 25? One is 25 over 25, so you subtract 7 over 25. All right, so there's cosine 2x. I'm 1/3 done. What about sine of 2x? Well, our formula for sine of 2x, why is that so glary today? Yeah, there's better. Sine of 2x is 2 sine x cosine x. If I close the shade, it'll be better. Right. Okay, very good. 2 is 2, I know that. Sine of x, I know. Do I know cosine x? I know cosine of 2x. Do I know cosine of x? No. What do? I find out cosine of x. Okay, how am I going to find out cosine of x? No, it has nothing to do with cosine 2x. It has everything to do with sine of x is negative 3/5 and x is in quadrant 3. So I'm going to draw myself a little triangle here. Here's my angle x. I know this is a right triangle. I know sine is negative 3/5, so how would I label this triangle? Opposite is 3, negative 3, okay. Hypotenuse is 5. And then I use the Pythagorean theorem. It happens to be a 3, 4, 5 triangle, except this actually has to be negative 4. And why does this have to be negative 4? Because I'm in quadrant number 3. In quadrant number 3, x and y are both negative. So you need to be careful that it does say quadrant number 3. So I can now look at this and I can say cosine of x is negative 4/5. So my answer here is 2 times negative 3/5 times negative 4/5, which is 24 over 25. Okay, so now I know sine of 2x. I also know cosine of 2x. What about tangent of 2x? Use sine over cosine. Yeah, I almost never use that cosine or that tangent 2x formula. If I want to find tangent of 2x, I almost always use sine of 2x over cosine of 2x. This is 24 over 25 divided by 7 over 25. I flip and multiply, I get 24 over 7. What's that? Negative? Where'd you get negative? Was there a random minus sign on your paper? Okay. Yeah, there shouldn't be a minus sign on your paper. All right, so those are known as the double angle formulas, and that's how we might use them. Questions on those? All right. Use the power reducing formulas. All right, we need power reducing formulas. Okay, so one of the identities we had a minute ago was cosine of 2x is 2 cosine squared x minus 1. I'm going to rearrange this formula a little bit. I'm going to add 1 to both sides. So this is 1 plus cosine of 2x equals 2 cosine squared x. And then I'm going to take this formula and I'm going to divide both sides by 2. So I have 1 plus cosine of 2x over 2 is cosine squared x. This is known as a power reducing formula. Notice on the right hand side we have cosine squared, but on the left hand side what do we have? Well, we have a bunch of stuff, but we have cosine to what power? Cosine 1. So this is a formula that allows us to go from having a cosine squared to having a cosine to the first power. So it's called a power reducing formula. Now, the penalty is to reduce your power, you get a bunch of other stuff in there, but that's okay. We'll use that here in a minute. And then I could do the same thing. We had cosine of 2x was 1 minus 2 sine squared x. And I'm going to do the same thing with this formula. Subtract the 1. Minus 1 plus cosine of 2x equals minus 2 sine squared x. And then I'm going to divide both sides by negative 2. So negative 1 plus cosine of 2x over negative 2 is sine squared x. This is usually written this way. Sine squared x is 1 minus cosine of 2x over 2. I multiply top and bottom by negative 1 to get rid of that negative on the bottom. When I multiply top by negative 1, I distribute through and I get that. So notice these two formulas are very similar. The power reduction for cosine squared is 1 plus cosine 2x over 2. The power reduction for sine squared is 1 minus cosine over 2. But notice, to reduce your power, the big penalty is you got to double your angle. Questions so far? You only have you know, okay. It's very confusing. All right, so what happens? Again, this is really something to prepare you for calculus. In calculus, we do something called integrals. And we do not have a technique for integrating cosine squared. But we do have a technique for integrating cosine to the power 1. So again, in calculus, when we have things that have cosine squareds or sine squareds or so on and so forth, we're going to use these power reducing formulas to get everything written using cosines. And then we'll be able to do it. So you might have a problem like this. Cosine squared x, sine squared x. And the directions will be write using only cosine to the first. So in other words, what we want to do is we want to reduce our powers. So I use my power reducing formulas. Cosine squared x. This is 1 plus cosine of 2x all over 2. And sine squared x is 1 minus cosine of 2x all over 2. And then what might you do with those? Multiply them together. All right. When you multiply the bottoms, you get 4. What do you get when you multiply the tops? You don't get cosine squared. 1 minus cosine squared 2x. What happened to the two middle terms when you do FOIL? Why do they cancel? Because those two things are conjugates. That's right. Notice they're exactly the same, except one has a plus, one has a minus. Those are called conjugates. So when you FOIL that out, you get 1 minus cosine squared of 2x. So we're not done. Because the direction said, write using only cosine to the first. Does our answer have cosine to the first? No. What does it have? It has cosine squared. So what do I do? No. I use the power reduction formula again. So my answer is going to be, I'm going to have 1 minus cosine squared of 2x, cosine squared of 2x. It's going to change because I have a 2x here. Because this is a 2x, when I plug in, I'm going to end up with a 4x. So this is 1 plus cosine of 4x over 2, and then the whole shebang is divided by 4. And we're done. Except it's kind of ugly looking, isn't it? Yeah, so what could we do to clean it up? Well, I'm going to take this and I'm going to multiply top and bottom by 2. Why did I pick 2? It'll get rid of the extra fraction. Yeah, in math terms, that's called a compound fraction or a complex fraction. It'll get rid of that 2 right there. Okay, so up on top I got to distribute. That's 2 minus, and then this 2 reduces there, so I have 1 plus cosine 4x all over 8. So final answer, I think I would write my final answer as 2 minus 1 is 1, of course, minus cosine 4x all over 8. So, in other words, sometimes you have to use those power reduction formulas multiple times. And that was a good example. Questions on that one? All right, now let's try an ugly one. I think that one was bad. Look at this one. This one has cosine to the fourth times sine squared. And again, the directions are the same, right in terms of the first power of cosine. So what are you going to do with cosine to the fourth? I could write this as cosine squared x times cosine squared x times sine squared x. You're exactly right. So if I have cosine to the fourth, I write it as cosine squared times cosine squared. Now I have a formula for cosine squared. So I plug that in. What was the formula for cosine squared? Ah, wonderful question. Do we have to memorize that formula? The answer is no. This formula will be given to you when you take your next test. All right, so here's our formula for cosine squared. It's 1 plus cosine 2x over 2. Yes, that's exactly what's going to happen. We're going to have 1 plus cosine 2x over 2. And then we're going to have that again. We're going to have another 1 plus cosine 2x over 2. And then sine squared, that one was 1 minus cosine 2x over 2. So what are we going to have to do this time? Cry. Yeah, but that won't help. It just smears the ink on your paper. Then you don't have to look at it. It's harder to read, though. Teacher gets angry. Well, I'll multiply the bottoms. Generous of me, huh? 8. What about up on top? Yeah, you're going to have to FOIL out one and then multiply by the other one. If I were going to FOIL them out, I would start by doing these two first because they're conjugates. So I would write 1 plus 2x, 1 plus cosine 2x, times 1 minus cosine squared 2x. Okay. Now I FOIL them again. When I FOIL again, I get 1. And then on the outside, I get minus cosine squared 2x. On the inside, I get plus cosine 2x. And then on the last, I get minus cosine cubed 2x. All divided by 8. Well, what I was thinking, I can't factor out cosine 2x because there's no cosine 2x in that term. What I was thinking is this one's done. That one doesn't have any cosines in it. That one's okay. That one's done. Why do I mean that one's done? It already has a power of 1, doesn't it? We don't have to worry about that one anymore. How about this one? That one done? No. So what am I going to do with that one? Kill it. All right. How do I kill it? All right. Well, I'm going to write 1 minus cosine squared 2x. Cosine squared 2x. What am I going to have? Except I already have a 2x here, so when I multiply by 2, that gives me a 4x. Similar to what we did last time. So this is going to be 1 plus cosine 4x over 2 plus cosine 2x minus something, and then the whole shebang still gets divided by 8. What do I do with this one? I factor out one of the cosines, and then left is a cosine squared 2x. And then I have to use that cosine squared formula yet one more time. So it looks like a potential final answer is, and I see I didn't leave nearly enough space to do this problem, 1 minus 1 plus cosine of 4x over 2 plus cosine 2x minus cosine 2x times, this one's now going to be 1 plus cosine 4x all over 2. And then once again, everything is still divided by 8. Some messed up stuff, I don't disagree with you. And I think I would actually do one more step. But the last step is easy. Again, I don't like these double fraction things that I have. So I'm going to multiply top and bottom all by 2 just to clear out the double fractions. Do you have to do that? No. It just doesn't look nice to me. I don't like it. So I'm going to do it. 2 minus 1 plus cosine 4x, because that 2 reduces with that 2, plus 2 cosine 2x, minus, and then this 2 reduces with that 2, so I have cosine 2x times 1 plus cosine 4x, really ran out of space there, all divided by 16. And I'm out of time for today, but the only thing I could do left, I could distribute this minus sign through, I could distribute this minus cosine 2x through, and that could be my final answer. I did. I thought of this as being over 1. So 2 times 1 is 2, and then this 2 cancels with that 2. So I multiplied these first, and I had a 2 on bottom, and then that 2 canceled with 2 on bottom.